Hey ladies, hope you guys had a wonderful break. So this is the last video of our chapters, super exciting. So with that said, we do have a test coming up here. We have an assignment tomorrow, so that'll be super exciting to work on. So today we're just going to be dealing with basically our trig functions, except they're going to be equations, which is really awesome. We're going to be looking at some real life situations involving our trig equations. So when we're using our sinusoidal functions, we can use them to model periodic phenomena that do not involve angles as the independent variable, which is kind of what we've been seeing. So some examples include the wave shapes, such as a heartbeat or ocean waves. We can look at pistons in a machine or the swing of a pendulum. And we can also look at circular motion, such as a Ferris wheel. So we can adjust the parameters a, b, c, and d, those constant values in our equations. We can adjust them to fit the form of what we would normally see here. So y is equal to a sine b times theta minus c plus d, and same with cosine. And we can do that to fit the characteristics of our phenomenon being modeled. This section we're going to be using graphing technology. By now you should hopefully know how to graph sine, cos. We're not really going to be looking at tan, but for this one, you know what, let's just use our graphing technology. I don't need to continually see you to graph it. If you can graph it once, I'm really sure that you can graph it after that. So we've had lots of practice up to this point, so we'll just be using some graphing technologies or your graphing calculators to solve this whenever I ask you to graph it. Alright, so for our first example here, we're just going to solve the equation over the specified interval. So we have sine of x is equal to 0.5, and that's over the domain of 0 degrees to 720 degrees. There's quite a few different ways to do this. I can discuss a few of them. Whatever works for you ladies is what you guys do. I'll show you a couple, and you pick one you want to do, and just work with that. As long as either way, that you should all get the same answer. Just do what works for you though, alright? So for this one, one option is to graph this, and there's two different ways we can graph this. We can graph sine of x, and every time our graph is at 0.5, that would be one of our solutions, assuming it's in between your domain 0 degrees to 720 degrees. Another option for graphing is that you could move your 0.5 to the other side, graph that, and then every time it's equal to 0 or crosses that x-axis, that is where your, or I guess that's where another value would be. So of course graphing isn't going to be the greatest. It can be often very inaccurate, especially if you're doing it by hand. Since you guys have graphing technologies, it should be fine. So, but for this example, we'll just graph sine of x, and then we'll just look for every point where it's at 0.5. So once again, if you guys wanted to do it where you subtract 0.5, you should get the exact same answer. Just look at x where it's equal to 0 instead of is equal to 0.5. So that's, I guess, one little difference there. So I'm just going to pull out my graphing calculator here. Right, so here's my graphing calculator, and I'm going to put it as y is equal to sine of x. If this will work, y is equal to sine of x. And here we get this wonderful sine graph, which hopefully you guys should look familiar. So now what we're going to do is we're going to find every place where y is equal to 0.5. So that's the point of this, why we're graphing this. So we want to find all the x values in between 0 degrees and 720 degrees where your x value is going to give you a y value of 0.5. So we can look here on our graph. So our first one here is approximately over here. Hopefully you guys can get a better little idea of it through your calculators. But looking here, we're at x is equal to 0.52, and it's about 0.497, and 0.525 is 0.0501. That's pretty close. So we could say that our x value will be 0.525. We don't want to get into any more crazy values there, so it's going to pause this and take a second there to draw this graph and make sure it goes from 0 degrees to 720 degrees on your sheet there. If your graphing calculator doesn't give to you in degrees, you guys can draw it in radians, and then from there pull out your x values there, so it'd be in radians, and then just convert your answer to degrees, and you guys should know how to do that. To be that value there is to be in radians multiplied by 360 degrees divided by 2 pi, and that should give you your value in degrees. So quickly pause the video there, ladies, draw that into your graph, then you can find out each value, or each time your x will give you a y value of 0.5, okay? So your graph will look something like this. You should know that 720 degrees is 4 pi, or 2 revolutions, so you should see 2 cycles here. So here's our first one and our second one. And then from there, what we can do is we picked out our first value. We have x is equal to 0.525, and that's in radians, and we want to convert that, so it's going to be equal to 0.525. Multiply that by 360 degrees, divide that by pi, or 2 pi, sorry. And what you should find out that we should have 30 degrees here. So that's for our first value. And then, so some different options that you ladies can do from here on out is you can keep using your graph and keep converting from radians to degrees, or you guys can use your cast rule and using your unit circle. Where is sine always positive? So using that, you have your in quadrants 1 and 2 where sine are always positive. So using your reference angle, you know that 30 degrees, and I'm just going to grab out paint. Alright, so using our reference angle here, say we have our 30 degrees, that looks, you're going to pretend that that looks absolutely wonderful. And knowing your reference angles, in our first quadrant here, or I guess this here is our second, 1, 2, 3, and 4. Our second quadrant here is going to be 30 degrees right there. So to find this angle here, going from all the way that way, it'll be 180 degrees minus 30. So you should find that x will be 150 degrees. Alright, so here we have x equal to 150 degrees. And if we want to keep doing it this way, just remember to get to the our second set, so going on from 360 degrees to 720, all we have to do is add a full pi to that. So, or I guess in this case we're dealing with degrees, so our other one will be 300 degrees plus 360 degrees, and that extra other value there will be x is equal to 390 degrees. And for our last one there, we should only have 4 values there, looking at our graph here. So there's one approximately here, there, around here, and there. So looking at that, yeah, you should only have 4 values there. So for our next one, it's going to be x is equal to 150 degrees plus 360. Putting that into your calculators, you guys should get 510, or if you guys can do that in your head, that'd be awesome. But you should get 510 degrees. Okay, so that is those are our values there. So whenever sine of x is equal to 0.5, our x values will be 30 degrees, 150 degrees, 390 degrees, and 510 degrees. All within that domain of 0 degrees to 720 degrees. Okay, so there is a few options there. I'll just repeat them. So first of all, you can graph them, and then from there you can pick out each point, and if you're obviously not given in radians, convert it using your conversion of 360 degrees divided by 2 pi. And then from there you can keep going using your graph and find out each point that way. Or if you find out your first point from your graph, you can use your reference angles and then continue to add a full circle to that, or 360 degrees. And one that I actually haven't mentioned yet was we could actually solve for when you have the equation sine of x is equal to 0.5. So I'm just going to write this off to the side here. So here we have sine of x is equal to 0.5. We want to get this variable here by itself, so we're going to do the inverse. So we have x is equal to sine inverse of 0.5. So you ladies put that into your calculators. Remember that we should be dealing with degrees and not radians. Remember our domain here is in degrees. So put that into your calculator, and you guys should get 30 degrees. From there, you can then you can use your reference angles and solve it that way. But yeah, so there are a bunch of different ways that you could solve this question. You pick which one you want to use. You should all get the same answer no matter what method you use. So pick which one works for you guys, and we can work with it that way. Okay, so question number 2, I'm not going to lie, it's a bit of an ugly question. No matter how you're going to solve it, you're just going to end up with a not so nice answer. But anyways, for this one, we need to find the general solutions for the trig equation that we have there. So it's 16 is equal to 6 cos pi over 6x plus 14. And here we're going to express our answer to the nearest hundredth. So there's a bunch of different ways you guys can solve this. Okay, so we're going to put this for graphic calculators. We have y is equal to 6 cos, and I'm going to get my brackets out here. Bracket pi over 6. Multiply that with just x. And we're going to be adding 14 there. Alright, so I'm going to adjust my windows here. And this is what you ladies should have approximately. So now what we need to do is we need to find each of those values where y is equal to 16. So looking at your graph here, I believe this here is our line here. And try and get to that value that is really, really close to 16, which 2.35, it's only 0.003 off. That's pretty good. So flipping back to our notes here, our first value here is x is, and it should be approximately equal to, I don't have this on Word, so make sure you do that in your notes, and x is approximately equal to 2.35. We'll deal with the general solutions in a bit. I just want to get my first values here. And so looking at our graph again, here another point where x is equal to, or our y value is equal to 16 is approximately, I wonder how close we can get there. Well, it's about 9.66. It's a little bit over. I wonder if you ladies can get to it. Oh, here we are, 9.65. That's pretty good. That's about the same place that we picked or pulled our other value out from. So it should be about y is equal to 9 or x is equal to 9.65. We'll flip back to our notes. And so here we have x is equal to 9.65. Okay, so we've got those two values, and that's the only time that they ever occur in their cycle. So now what we can do is we can find the general solutions. So I'm going to flip back to our graph once again. And so what we should notice here is that it only happens at those two values. Those are the only two values where it's ever at y is equal to 16. So we can just say that that is for one cycle. So now we need to do for general cycles, and so it should occur every time we have, I guess, every new cycle. So you guys could figure this out just by looking at your graph here. So here we have 16 would be at 14.35. We have 14.35, and if we actually look at that distance, it is equal to 12 there, which, if you ladies actually notice, it is the same distance, I guess, as our period. So what you'll notice is that 2.35, you add your period, and you get 14.35. So your period here, if you were to put that into, say, your equation of 2 pi divided by b, that's your equation for the period, you would find that it is equal to 12. So what we can say is that x is equal to 2.35 plus your period, which is 12, and it's the general solution, so we're going to give it a variable n, where n is equal to, or n is an element of integers. Okay, so that's for the first one. For the next value here, ladies, if you wanted to do the same, you could go back and find a second value and kind of find out where that period is or how often it repeats. You guys can do that again, but we already know it here, so we can just go, I guess our general solution here is x is approximately equal to 9.65 plus your period, so plus 12, n, where n is an integer or element of integers. Okay, so hopefully that makes sense. Ladies, just ask me if you guys have any questions, just make sure you feel free to stop me. But hopefully we should get how to find out the general solution. So it's, you find those points each time it occurs during your cycle, and then from there you just add your period with your variable n, so that we can count for a number of periods, I guess you could say. Alright, so number 3, I'm going to switch over to, we're going to do video number 2 to solve question number 3, because I'm running out of time here. Remember, I'm only allowed 15 minutes, so I'm going to stop here and we'll switch over to video number 2.